Well, hey everybody. We're going to be covering some more material on market structure today. So let's get right into it. We're looking at the in-between market structures of monopolistic competition and oligopoly. So when we look at market structure, really we're looking at market structure along a continuum. So on one side, and we've already talked about this, we have competition, and on the other side, we have monopoly. Those are the extreme market structures. But in the real world, most things are somewhere in the middle. So we don't have those perfectly competitive markets, and really it's hard to find a perfect monopoly for all intents and purposes. The two market structures, the two ways we define market structure in between these extremes are, first of all, monopolistic competition. And as you can see along our continuum here, this is closer to competition, and you'll see why here in a minute when we get to the details of that market structure. The other market structure is oligopoly, and that is along our continuum closer to monopoly. So really what we see is that in this middle part is where we see most market structures in the real world. So let's deal with monopolistic competition first. We're going to spend not a whole lot of time here. We'll spend most of our time with oligopoly. But when we look at monopolistic competition, there are very few barriers to entry, if any barriers to entry. So that helps to make it more competitive. There are lots of sellers, so that makes it more competitive as well. But where we start to see some degree of monopoly power is in the reality that in monopolistic competition, there is product differentiation. So firms are able to distinguish their product from other people. And consumers are not indifferent between the goods. If given a choice, they will tend to move in one direction or another, which gives the firm some market power. And just think about your favorite fast food restaurant. Just the fact that you have a favorite fast food restaurant means that in that type of market, somebody is selling you something that you prefer. There's not a ton of differentiation, so you go in one direction or another. And there are lots of different ways that firms can differentiate themselves. You can differentiate yourself on location. So if you see this gas station down here in the lower right-hand corner, that's a gas station in the middle of nowhere. They have some value because they're in the middle of nowhere, and if somebody needs them, then there they are. But if you think about something closer to you as far as gas stations are concerned, just because the gas station is on one side of the road or another, because it's on a corner, because it has easy access, that allows that firm to essentially be differentiated from each other. Packaging, what does the product look like? The physical features of a product, people's tastes, service. So the Nordstrom department store is known far and wide for its customer service and its outstanding customer service, and that helps to differentiate it from other department stores. Things like convenience. Just walk down the cereal aisle, and you will see product differentiation on a lot of different fronts. Whether it's sweetness, whether it's crunchiness, whether it's the color of the packaging. There's lots of different ways that firms differentiate themselves. Now, monopoly is also part of monopolistic competition, and that product differentiation gives the businesses in that setting the ability to set prices. And because they can set prices, they're not pure price takers like the competition. They're price makers, at least to an extent. And because of that, their demand curve is going to be downward sloping. Now, this is not the market demand curve like we saw with monopoly. This is the demand curve faced by the firm. But the demand is fairly elastic because there are lots of sellers, and as a result of that, there are lots of substitutes. Again, think back to your favorite fast food chain. If, let's say your favorite place is Chick-fil-A, and Chick-fil-A decides to double the price of their chicken sandwiches, it's not like there aren't alternatives. And Chick-fil-A may see a substantial decrease in the number of customers because demand is relatively elastic. So here's the monopolistic competition model. We're going to set this up so that it looks basically like a monopoly model. And here's the demand curve. Here's our marginal revenue curve. And here's our marginal cost curve. So if we throw in an average cost curve, something that looks like about like that, then we would find our output just like we normally would. We'd go here, where marginal revenue equals marginal cost, go up to the demand curve and across, there's our price, and there's our quantity. So this looks just like the monopoly model. Where things are different, though, is because this demand curve is just the demand curve for the firm, and because we can see that this firm is earning profits, there's going to be entry into the market. So these profits are only short run in nature. And the entry into the market is going to shift this firm's demand curve, or more specifically, the demand for what this firm produces. So let's see what that looks like. Here we have the demand curve, downward sloping, the marginal cost curve, and the average cost curve. I've just taken these from the previous graph. I left out the marginal revenue curve because it just makes things a little bit messy. Now what happens is that with entry, the demand for this particular firm shifts downward, and we have a tangency right here. It is important that we have a marginal revenue curve here, because now we can find where this firm's profit maximizing output's going to be right here, and the new price that it's going to charge. Now that price is going to be lower than originally, and what we see is that this spot, and we'll just highlight it a little bit more, this spot right here, where the tangency of the average cost curve and the new demand curve are, that ends up being the price. So we have price equal average cost for this firm. So they're covering their costs, but price is above marginal cost. So they are charging a markup, but they aren't observing long-run profits because now price equals average cost. One other thing to notice about this is that, and we'll talk more about this in a minute, is that we're not at the minimum of the average cost anymore. So that's one of the things that makes monopolistically competitive markets different from competition. We aren't producing at the minimum of the average cost, and it's different than monopoly because we're not earning long-run profits. So as we just saw, the monopolistic competition model looks a lot like a monopoly, but it isn't for a number of reasons. First of all, and most importantly, the downward sloping demand curve is faced by the individual firm. It's not the market demand curve. We have to sum up all of the demand curves for each individual firm to get the market demand curve. In monopoly, because there's only one seller, that one curve is the market demand, but that's not the case here. Secondly, we have no long-run profits because it's relatively easy to get into and out of the industry. So unlike monopoly that can have perpetual profits, the monopolistically competitive firm cannot. Furthermore, the long-run equilibrium ends up being a result of firms responding to the profit incentive. So they enter if there are profits, they exit if there are not profits, and in the long run, we get to a point where there's no entry and exit. There's also no long-run profits, so that's when that entry and exit stops. That being said, the long run is clearly like competition because there are no long-run profits. It's like monopoly because of the downward sloping demand curve. Another reason that makes it like monopoly is that the price charged by the firm is going to be above the marginal cost. Now, in monopoly, that gap can be pretty big, but in monopolistic competition, because the demand curve is pretty elastic, the gap between price and marginal cost is not going to be very big at all. So, the question of should we regulate a monopolistically competitive industry comes up sometimes. The answer is probably not, because even though there is a markup over marginal cost, it's not going to be very big. And firms compete. Firms compete pretty vigorously in the monopolistically competitive world. They can compete on price. They can also compete on how they differentiate themselves. So how do I set myself apart from my competition? And that leads to a lot of alternatives for consumers. It leads to a lot of choice for consumers, and it leads to a lot of new products being produced by the firms. Still, there are some inefficiencies in monopolistic competition. The question is how significant are those inefficiencies? First of all, as we saw in the graph, the firm is not producing at the minimum of their average total cost curve. They could produce a different quantity and produce it at a lower average total cost, but they don't. That's inefficient. Secondly, the output that's produced is not the same output as is in competition. It's below what society would view as the optimal amount. So that's another form of inefficiency, where the firms are producing a little bit less than what would happen in competition. As a result of that, we end up with some deadweight loss in monopolistic competition. Still, we refer back to the question of whether or not that deadweight loss is sufficient enough to encourage regulation of the market. And for the most part, the answer is no. We don't want to come in and regulate a market where the deadweight loss is likely pretty small. Now that brings us to our other market structure. That is oligopoly. And oligopoly is, well, it's a different kettle of fish. With oligopoly, we have just a couple of firms, and we can have as few as two, which would be called a duopoly, and that's how we're going to perform most of our analysis here. The products that the firm sells might be differentiated, and they may not be differentiated. It just kind of depends. Gasoline is not very differentiated. There are some slight variations with higher octanes and whatnot, but if you have gasoline that's too different from somebody else's gasoline, then you're going to put it in your car, and your car's not going to work. But sometimes products are very differentiated. They're very, very substantially different. These firms, because there are just a few, because there is some amount of product differentiation, they do have some market power. They might differentiate on the quality of the product or the location or any of these other various aspects. But the key thing for oligopoly, the key part of all of oligopoly and understanding it, is that the output and pricing decisions that are made by the firms are interdependent. We can see this by looking at the other market structures that we've talked about. A monopolist doesn't need to react to its competitors because it has no competitors. In competition, the firms don't have to react because they're price takers. And they're so small and insignificant in the whole scheme of the market that there's really nothing for them to react to. If somebody else increases their output, it's not that big a deal because it's not that much of the market. But in oligopoly, firms had better be reacting to what the other firms do, because if one firm lowers prices, they can end up taking all your customers. If one firm creates a new product line, they can take away some of your customers. You need to be on your toes. You need to be reacting to what's happening in the market. What you do affects your rivals, and what your rivals do affects you and your success and your profitability. So what we say is that the output and pricing decisions of one firm end up affecting the decisions of all of the other firms. That's oligopoly, and that's what really makes it unique. But it also makes it problematic. With oligopoly, we have no single oligopoly theory. We have the monopoly model, we have the competition model. We really even have one model just for monopolistic competition. But in oligopoly, that's not it at all, because strategy affects the outcomes. And as people adopt different strategies, there are different approaches that can be taken to the oligopoly setting. So what we say about oligopoly is that for each different modeling of reaction and strategy, there's a different oligopoly theory. And there are dozens of oligopoly theories. We're not going to look at dozens of oligopoly theories. We're only going to look at a couple. But there are lots of different ways to approach the oligopoly. One way to do that would be through what's called the Cournot model. This is like the classic oligopoly model, where we have two firms, they're on equal footing in the markets, and their decisions end up being, in terms of output and price, tend to be pretty similar. There's the Von Stackelberg model, in which case we have one firm that's a leader and another that's a follower. And that ends up changing the outcome of the model, because the leader ends up being more profitable than the follower. And then we have something called the Chamberlain model. The Chamberlain model is a model of collusion, because in oligopoly there's something else we have to consider, and that is whether or not the firms might get together and gang up on the customer and act as a monopoly even though there are multiple firms. So there's lots of different things we need to look at when we look at oligopoly. So before we get into those different ways of looking at oligopoly, I want you to be warned. The models that we're going to look at, the models of strategic behavior, require pretty careful attention. They're going to look more complicated than what we've seen thus far in the course. So you need to pay attention. Now, that being said, if you're able to concentrate on these things and pay attention, they're pretty systematic. They're pretty. It's a pretty clear process that we're going to follow here, but you got to have your head on straight. Okay, so let's take a look at the assumptions of our models. Again, as I mentioned, we're going to look at models as if they were duopoly. So we're just going to have two firms. It makes the analysis just a lot simpler. The outputs are going to be just considered as output 1 and 2, x1 and x2 for the two different firms. Both firms are going to be assumed to be trying, we're going to assume they're trying to maximize profits. So those are the basic assumptions. And now we're going to start to put this stuff together. We need to begin, though, with a basic understanding of how we set these up. So to set up the basics of our oligopoly model, I'm going to go back to something that we've looked at once before, which involved just finding out the profit maximizing output for a firm. If you remember, we had a total cost curve. It looked something like this. And we had a total revenue curve that looked something like this. And what we did was we found that there were different profit amounts depending upon how much output was produced. So for instance, if we produced here, or if we produced this amount of output out here, we had zero profit, because that's where the firm breaks even. So I'm just going to label that as pi sub 0, those outputs that correspond to those two particular output amounts. And as we moved closer to the middle, there were pairs of outputs that would yield the same profit. So for example, we might just call this pi 1, but there's another pi 1 over here because it yields the same profit, those two amounts. But there was somewhere where there was only one profit, a unique profit, the profit maximizing output. And I'm just going to call that pi 2 for now. But in between pi sub 0 and pi sub 2, there are all of these infinite number of pairings. So we have two different quantities that would yield the same amount of profit. Now what we're going to do is we're going to take this information and put it into a separate graph that's just going to look at profits. And we're going to add a second firm, because firm 1's profit is dependent upon not only what they choose to do, but what the other firm chooses to do as well. So here's what we're going to do. We're going to take those different output amounts that yield different profit amounts. We'll put a pi 2 there. Oops, a pi 1. Sorry, pi 0, pi 1, pi 2, and then here's pi 1 again, and pi 0. Along the vertical axis, we're going to have the output for firm 2. So our isoprofit curves are going to tell us how much profit firm 1 will earn depending upon what firm 2 does. Now the easiest place to start is right here. At this red dot, pi 2 is the profit maximum, and that occurs when firm 2 produces no output. And basically what we're saying here is that firm 1 is the monopoly. If firm 1 chooses output over here or over here, they will earn a smaller amount of profit. But if and that's if firm 2 produces nothing. But if firm 2 starts to produce something, then firm 1 has to alter its output to stay at profit level pi sub 1. So there are these various output combinations between firm 1 and firm 2. So if firm 1 chooses this amount here and wants to continue to make pi 1 profit, that would be consistent with firm 2 producing this amount. And if firm 1 is breaking even, that can happen at a lot of different output levels as well, depending upon what firm 2 produces. So these various hills, if you will, are the isoprofit curves. They're telling us different output combinations between firm 1 and firm 2 that yield the same amount of profit. The closer you are to that red dot, the more profit you have. So higher profit is the isoprofit curve, or is output that puts you so the higher the isoprofit curve you are, basically, so think about it this way, this direction is down. So that red dot is like the peak of a mountain, and anywhere you go from there is down. So you're going to have less profit the further away you get from that red dot. And we can do basically the same thing here for firm 2. So if we have our setup just like this with x1, this is output for firm 1 and output for firm 2. Firm 2 is going to have a profit, a pi 2 amount, the maximum profit right there. That is if firm 1 produces 0. And then around that, there will be these isoprofit hills. And the further away you get from the red dot, the less profitable you are. So we have our firm 1 and our firm 2 isoprofit maps. Now we're going to use those isoprofit maps to help us to identify what's called a reaction function. So let's go back here to firm 1 and their isoprofit curves. So these are the isoprofit curves for firm 1. And for firm 1, if we connect the tops of those hills, what we're going to find, or the place where the slope would be 0 of those hills, and we connect those dots, we're going to see a line that starts to bow over there towards the y-axis. That line is called a reaction function. The reaction function is the best output for any firm given what the other firm produces. So if firm 2 produces this amount of output here, so we'll just say this is x2. What firm 1 wants to do is go across to its reaction function and produce that amount of output, because that's the best they're going to be able to do. That's the highest isoprofit curve they'll be able to get on. And as we see here, this is just about right here. So that's the best isoprofit curve they can get given what firm 2 produces. If firm 2 produces less, that's good for firm 1, because it puts them on a more preferred isoprofit curve. The reaction function for firm 2 is found in the same way. So we'll just draw this one last time. We connect the peaks of the hills, and that kind of starts to taper down towards the x-axis. And this is firm 2's reaction function. Firm 2's reaction function. Now those similarly, if firm 1 produces this amount of output here, then firm 2 wants to be on their reaction function, and they will produce x2 amount of output. If firm 1 produces a lot more, if they're way out here, well, the best that firm 2 can do then to get to their highest profit amount would be to actually reduce output. So what we were talking about earlier is that each firm's profit and pricing is interdependent upon what the other firm does. Well, now we see that more clearly here with the reaction functions. Okay, so if we put those two reaction functions together, what we end up with is one of our basic models for oligopoly. In this case, we are looking at the Cournot model. So I mentioned a little bit earlier that the Cournot model is the model where each firm assumes some things. They're relatively similar sized firms, and the assumption is that each firm holds its output constant. So I'm going to choose my output based on what I think your firm is going to do, and I think that you're going to hold your output constant. So if I'm firm 1 and my reaction function looks like this, and your firm 2 and your reaction function looks like this, guess where the equilibrium is going to be? If you said right here, you are absolutely correct. Give yourself a cookie. And here is how much output I would produce, and here's how much output you would produce. Again, the red curve is firm 1, firm 1's reaction function, and the blue curve is firm 2's reaction function. So we find where the lines cross, and that gives us our equilibrium output. And I may ask, well, how in the world are we going to get there? Why would we end up at that point? And the answer is actually pretty simple. It's that every time a move is made by me, you are trying to get back to your reaction function. And every time a move is made by you, I'm trying to get back to my reaction function. So let's say that, well, let's clean this off first. Let's say that I start over here. And I say, this is how much output I am going to produce. Let's say out here. So this is where I start. You, seeing that and assuming that I'm going to stay there, you're going to go up to your reaction function and you're going to produce that amount of output. Now, I see that, and eventually I do respond to it, and I say, if you're going to produce that amount of output, well, I want to be on my reaction function, so I'm going to decrease how much I produce to get here to x2. And then you look at that and say, well, if you're going to produce x2, then I am going to go to my reaction function. So this is like x2b. And then I look at that and I say, well, if that's what you're going to produce, I'm going to move over here to my reaction function. And so there's my new output. And this is just going to keep going back and forth until we get to that equilibrium point. And if we go past that, so if we end up over here somewhere, then the process will work in reverse. So each of our firms, my firm and your firm, has this incentive to move to the point where we get right there, where we're both on a reaction function. That makes us both better off. This also allows us to take a look at how mathematically we would get to this point. So if we have two identical firms, and by identical I mean in every way, shape, or form, if each one of our marginal costs is 10, and if the market demand curve is P equals 100 minus Q, where Q is equal to Q1 plus Q2, then I can figure out exactly how much output each one of our firms should make. What we're going to do is we're going to go to that reaction function, we're going to use that reaction function, and we're going to solve for how much output each firm should produce. So what does that look like? Well, here's my firm, Q1, or my output, Q1 for firm 1. My reaction function, I'm going to say is R. That's my reaction function. I'm going to put a little subscript 1 there so I know that I'm talking about firm 1. And it is based on how much output, small letter q, of firm 2. So if Q2 equals 0, then that means I'm going to act like a monopolist. I'll just set marginal revenue equal to marginal cost, and I'll solve. There won't be any demand for your firm's production because, well, you're not producing anything. For firm 2, since the costs are identical, then what we see is that your reaction function is exactly the same as mine. We just changed the letters around. So Q2 is equal to R2. That's your reaction function. It's a function of, or your output is a function of what I produce. And again, if Q1 is equal to 0, then you are acting as the monopolist. You would set marginal revenue equal to marginal cost and figure out your output. We know based on the graph we just looked at that the reaction functions would be equal to each other. So all we have to do is set these two reaction functions equal to each other and solve the equation. So that would mean Q1, which is equal to the reaction function based on what you produce, is equal to the reaction function, your reaction function, as a function of what I produce, and that equals Q2. So we're going to set this thing equal to each other and solve to find the equilibrium. The equilibrium is going to be a point where both firms maximize profits based on what we believe the other firm is going to do. Neither one of our firms is going to want to change at all. So let's set this up as an example. Let's say we have two firms. Once again, we're going to say the marginal cost, we're going to have that equal the average cost. We'll say that's 10. And again, the market demand is P equal to 100 minus capital Q. And we'll have firm 1 and firm 2. Let's say we're dealing with two airlines. So we have airplane manufacturers. We'll have firm 1 be Airbus and firm 2 be Boeing. And they're trying to decide how much output to produce. Well, we know what the marginal revenue curve is going to look like. We just take our twice as steep rule. So there's marginal revenue is going to equal 100 minus 2Q. Now, if Airbus acts as the monopoly and they assume that firm B has an output equal to 0, then what they will do is they'll set marginal revenue equal to marginal cost, which is 100 minus 2Q equal to 10. We do our algebra here, that gives us 90 equal to 2Q. So output for the monopoly firm would be 45. Drop that back into our demand curve, and that means price is going to equal 55. So this is the monopoly output. This means for Boeing, they're just out of business. We can look at quantity here as being, again, Q is equal to QA plus QB. QB equals 0, so QA gets all of the output. So even though firm B is not producing anything, there is still a demand curve there. It's something we refer to as the residual demand curve. It's what's left over. So if our demand function looks like this, and Q is QA plus QB, then our demand function really looks like this. Now if QA is equal to 45, as we just found out, then what we have is, and I've distributed the negative sign here, we have a residual demand function for firm B, for Boeing, that looks like this. That is the demand curve that Boeing is facing. So now we can construct a demand curve based on this, and then we can start to solve the reaction of Boeing to what Airbus is doing. So let's do the demand curve first. The demand curve looks like this. So here is, just to remind ourselves, here is the demand function. So our y-intercept is 55. Our marginal cost is 10. Just draw that across there. The slope is 1 or minus 1, so that means that we're going to intercept our x-axis down here at 55. So all we do is connect those dots, and that is the demand curve that is faced by Boeing, firm 2. We know the marginal revenue is going to split this angle here. It's going to bisect. It's going to be twice as steep. So what we need to do now is, with some degree of specificity, find out what is this quantity that Boeing is going to try to produce. So all we do is set the marginal revenue of Boeing equal to the marginal cost. So that's 55 minus 2QB. Set that equal to 10. That means 45 is equal to 2QB, which means that QB is equal to 22.5. So there's the output that Boeing responds with if Airbus assumes it's the monopolists and produces 45. But this changes the total industry output now. So total industry output is 45 plus 22.5, or 67.5. That's our new output, which means it's going to change the price. So we put 67.5 back into our original demand curve, and price is going to equal 32.5. So this is the process. Now, what's going to happen is Airbus will see what Boeing did. It's going to respond to that. And so Airbus, so again, this is firm A and their demand curve. Here's what they're facing. Their demand curve is P is equal to minus 22.5, that's quantity A, minus, quantity B, minus quantity A, what they would produce. So this is 77.5 minus QA, which means our intercept is 77.5 up here. It's 77.5 down here. We connect the dots, and that's the demand curve now for firm A. There's our 10 as our marginal cost. Marginal revenue curve bisects the angle, and we want to find out what's the new quantity that's going to set marginal revenue equal to marginal cost. So we know marginal revenue is going to be 77.5 minus 2QA. We set that equal to marginal cost of 10. That gives us 67.5 equals 2QA. So QA is 33.75. That's this amount right here. So now the industry quantity has changed once again. The industry quantity is 22.5 plus 37.5. So this is QA, this is QB. The total is, oops, sorry, what did I get wrong there? 33.75. There it is, 33.75. So that gives us a new industry quantity of 56.25. And that gives us a new price of 43.75. So what's going on here is we're just going back and forth, making the, seeing how one firm responds to what the other does. And this goes on and on and on. We could continue this onwards until both firms face the same residual demand curve. So the process ends when both firms face the same residual demand. And as a result of that, both firms are going to produce the same output. This is something that we refer to as convergence. Now that convergence is going to occur when both firms face the residual demand curve that looks like this. So now what we can do is set marginal revenue equal to marginal cost for both firms. We find out that each firm is going to produce 30. So the industry output is 60. If the industry output is 60, then the price is going to equal 40. So that's what we would end up with. The question is, do we have to go through all of this calisthenics to get there? Isn't there an easier way to get to this point? And the answer is, of course there is. Of course there is. So let's see what that looks like. So what we need to do is we need to find the total revenue for a firm. Of course, total revenue is equal to price times the quantity, but in this case, we're looking at the quantity for the specific firm. So if we're looking at firm A, Airbus, then we're going to take the market price times the quantity for Airbus. And remember that our demand curve looks like this. 100 minus QA minus QB. So we can use that demand curve to substitute in for our price. So 100 minus QA minus QB times QA equals the total revenue for the firm. So we'll just distribute that QA, 100 QA minus QA squared minus QB QA, and that equals total revenue. The marginal revenue is the first derivative of total revenue with respect to QA. So marginal revenue would become 100 minus 2QA minus QB. Now we can set this equal to our marginal cost to solve for the missing output, or for the output of interest here. So marginal revenue equals marginal cost. Remember, marginal cost is 10. So we set these two things equal to each other, which means 100 minus 2QA minus QB equals 10. Now, it's important here to remember that we are looking for QA. That's what we're trying to solve for. So, to do that, what we're going to do is bring the 10 over. We'll have that be 90 minus QB, and set that equal to 2QA, then divide each side through by 2, which gives us 45 minus 1/2 QB equal to QA. So now we have a value for QA that we can put into our identity for the reaction function. This is the equation for the reaction function. So this is firm 1's reaction function, or firm A. Because the reaction functions in this model are the same, all we do is change the letters around to get the reaction function for firm B. So let's take a look at that. Firm B's reaction function is 45 minus 1/2 QA, which is equal to QB. So we're going to take the reaction function we just solved for, that value for QA, and we're going to substitute it into this reaction function. So we'll have 45 minus 1/2, 45 minus 1/2 QB, that's the value of QA, and we'll set that equal to QB. And now we can solve for one unknown. So we have 45 minus 22.5. And here's the part that is easy to screw up. We have a minus 1/2 times a minus 1/2. So that's a plus 1/4 QB equal to QB. Now we just need to simplify this. So 22.5 is equal to 3/4 QB. Multiply each side of this equation by 4, which gives us 90 equal to 3 QB. Divide each side by 3, And lo and behold, we have our value for firm B. This is the amount that they will produce is 30. If we take that 30 and put it back into the reaction function for firm A, so that's this, 45 minus 1/2 QB, we can put a 30 in for there, and that gives us 45 minus 15, which gives us a 30 for QA. Now we have our total market quantity, which is just these two numbers added up, which is 60. We put that 60 into our demand function, which was 100 minus Q, and the price is equal to 40. So what we did was we solved for the first reaction function, then took that reaction function, substituted it into the other firm's reaction function, and then solved for one unknown. One of the things that's nice about the Cournot model is that in this model where you choose output, the Cournot result is pretty realistic and it's pretty reliable. It's a pretty stable equilibrium. There's not much incentive to move from this. But the last thing I want to do is take a look at Cournot and compare it to what we would see in the monopoly case. So let's do that. If this was the monopoly case, remember we had already solved for the value of the output. So Q was equal to 45 and price was equal to 55. Compare that to Cournot, so this is the monopoly. Compare that to Cournot where quantity was 60 and price was 40. We see a result that we should have expected. We see that quantity goes up and price comes down in an oligopoly compared to monopoly. If we look at the profits for the two different firms, we should also see a clear distinction here. We should see that monopolies have higher profits and oligopolies, at least the Cournot oligopoly, has a lower profit. So remember, when we calculate profit, we're taking total revenue minus total cost. Total revenue is price times quantity. Total cost is marginal cost times quantity. So for the monopolist, we have 45 times 55 minus 10 times 45, which gives us 2,475 minus 450, or a total profit of 2,025. Compare that to the Cournot outcome, where we have 40 times 60 minus 10 times 60. So we have 2,400 minus 600, which gives the Cournot profit of 1,800. So we see that profits are lower in the oligopoly model as well. Now the Cournot model is a model where firms cooperate, sort of cooperate. They're on equal footing. But in our next model, the Von Stackelberg model, we see a very different outcome. This is the leader-follower model. And the idea here is that if you observe somebody playing the Cournot or taking the Cournot strategy every time, you could possibly exploit those people. You exploit the repetition. So the other firm presumably never catches on, and the leader's model or the leader's output goes up. And so what the leader does is to find the point it likes best on its rival's reaction function and chooses its own output so that it forces the rival where it wants to go. Now, let me show you what that looks like. I think it'll be easier and trying to explain it in words. So once again, we have output 1 here and output 2 here. We have our two firms' reaction functions. So this is firm 1's reaction function, and here's firm 2's reaction function. The Cournot equilibrium, of course, is where those two lines intersect, but that's not what's going to happen in this case. What's going to happen is that firm 1 is going to try to get to a preferred isoprofit curve by finding a curve that's just tangent to firm 2's reaction function. So at this point, firm 1 produces this amount. We'll call it X1 V for Von Stackelberg. And then firm 2, expecting that will be firm 1's permanent output, produces this amount. But if we were to compare that to the Cournot result, so here's our Cournot result with a green dot, the Cournot output for firm 1 is a lot less, and the Cournot output for firm 2 is higher. So what's going on here is that firm 1's basically pulling a fast one on firm 2. They're increasing their output to make it more profitable for them, for firm 1, at the expense of firm 2. Now the problem here is that this is a pretty unstable equilibrium, because if firm 2 finds out what's going on and tries to become the leader by increasing their output, things could get kind of messy. It's entirely conceivable that firm 1 keeps its output at X1V. Firm 2 increases its output and puts everybody at some amount way out here, here, where firm 1 is producing X1V and firm 2 is producing some amount even higher. So now both firms are beyond their reaction functions in a place where they don't want to be. So the Von Stackelberg can lead to some trouble. So let's see what the math looks like behind this. One of the things that we're going to see here is that this is a very different outcome from the Cournot outcome. It's basically what we call a two-stage sequential game. So here's the process. Again, we'll assume that Boeing is the leader and Airbus is the follower. We'll start off with the same demand curve, and we'll keep marginal costs the same. So Airbus's reaction function, we've already figured this out, because they're going to be presumably playing, sorry, this is Airbus, they're going to be presumably playing the Cournot strategy, so we're going to return their reaction function to where we were when we looked at Cournot as 45 minus 1/2 QB. Boeing knows this and sets its output, and then Airbus reacts based on its reaction function. But we're not going to do that substitution that we did with Cournot because Boeing's not following their reaction function. Instead of inserting the reaction function of Boeing into this equation, we're going to insert the reaction function into the demand function. So take this and put it in the demand function. And then we'll solve. So let's do that. Here's our demand function. With Airbus being the follower, we're going to put 45 minus 1/2 QB into that demand function. Then total revenue is going to be this whole thing times QB. And now what we're going to do is we're going to kind of condense this, figure out the marginal revenue, and set that equal to marginal cost. So let's go through and do that. So 100 minus 45 minus 1/2 QB minus QB. That's our price, and we're going to multiply that times the output QB. So let's reduce this down. We have 55, and then we've got a negative sign out here. So we need to be careful what we're doing here. So 100 minus 45 plus 1/2 QB minus QB times QB. So let's reduce this before we do our multiplication. 55 minus 1/2 QB times QB. So that gives us 55 QB minus 1/2 QB squared. So that is our total revenue. Marginal revenue is the first derivative. So marginal revenue is 55 minus, we're going to bring this 2 out front, this exponent 2 out front. So it'll be 2 times 1/2 times QB, which is just QB. And that equals our marginal revenue. Now we set marginal revenue equal to marginal cost to solve for QB. So we have 55 minus QB equals 10, which means that QB is equal to 45. So this is the liter's output. Now for the follower, which is of course Airbus, we're going to take that 45, drop it into their reaction function. So that would be QA equals 1/2, oops, hold on a second. QA equals 45 minus 1/2 times 45, and that's going to give us 22.5. So clearly, we've got something different going on. We have the two firms producing different amounts of output. The total market output is now QA plus QB, which is equal to 45 plus 22.5. Oops, let's do it the right way. 22.5 plus 45, which is 67.5. And then the price is equal to 100 minus 67.5, which is 32.5. So in the Von Stackelberg setting, Airbus is on its reaction function. But Boeing, the leader, is not on its reaction function. What we've done is we've found a better alternative to get us on a better isoprofit curve. But of course, things can get wonky here, and if Airbus reacts to what is happening, then they might start to ramp up their production. If they see that Boeing is producing 45 and they produce 45, then output shoots up, price falls, and profits fall as well. So let's do one last thing with the Von Stackelberg model. And it's this. Let's compare Von Stackelberg
to the Cournot model. And what do we end up with? Well, for Von Stackelberg, let's do it like this. Output, price, and profits. So here's Von Stackelberg, here's Cournot. The output in Von Stackelberg was 67.5 as compared to Cournot, which was only 60. So output is bigger. That's good. Price for the Von Stackelberg was 32.5 as compared to 40. So price is lower. So that's good. And when we look at profits, well, we figured out the profit for Cournot. We already figured out the profit for Cournot. We saw that that was 1,800. For Von Stackelberg, we take the price times the quantity. We're just going to look at the market quantity here and subtract the marginal cost, which is the same for both firms, times the market output. So we take 67.5 times 32.5 and subtract 67.5 times 10. And when you do that, you end up with $1,518.75, which is less than Cournot. So this is kind of interesting. With the leader-follower model, there's certainly one firm that does better, but the Von Stackelberg outcome gives us an outcome that is slightly more like the competitive market, where there's larger output, lower prices, and lower profits for the firms.
Well, that's a lot of math and a lot of graphs. I think it's a reasonable question to ask yourself, who in the world does any of this stuff? Other than economists, of course. The oligopoly model is actually a really important one in policy and in legal realms. But lawyers and judges and policymakers don't like working with ISO profit curves or reaction functions or the math. Instead, what they do is they use something called the working theory of oligopoly. To understand the working theory of oligopoly, we first have to understand what you're trying to analyze as you're looking at these different firms and what's the real question. The question is whether or not firms are acting too much like monopolies. In other words, are they acting like a cartel? A cartel is when a couple of firms get together and coordinate their action with the express purpose of maximizing their joint profit. Firms, if they're performing like a cartel, are going to restrict output to keep their prices and their profits high. Now that's, at least in the United States, that's illegal. So when regulators and when the judicial system is functioning and trying to identify this type of behavior, they're basically looking to find illegal activity. An idealized cartel is going to behave like a monopoly, where they get together, they jointly determine what's the profit maximizing price and output, just like a monopoly would, and they charge that price and produce that output, and then split the production between the firms. Cartel theory is sometimes known as cooperative oligopoly, and in many policy discussions, this is the theory used. Again, it's not the analytical stuff that we've already examined here. It's essentially trying to gather proof of whether or not firms are engaged in certain anti-competitive behaviors. If you've ever seen the TV show Narcos, this is drug cartels trying to behave as joint profit maximizing behaviors or joint profit maximizing entities. Again, this is the model that the lawyers and the judges know. So within the model, what we see is that there are two opposing forces. And we see this in any industry where the firms say at least they would like to have joint profit They would like to maximize profit for the whole industry. And that would lead us to the collusive result. It's the Chamberlain equilibrium that we examined. It's the oligopoly solution. But while that is it is fine to desire that, there are forces in the markets that are working against that behavior. The central insights of the working theory of oligopoly is that, or are that, one of them anyway, is that cheating destroys the joint profit maximization. Cheaters never prosper. It's certainly the case in the working theory of oligopoly, at least eventually. But there's this incentive to cheat because in the short run, cheaters might prosper significantly. So we have this, this inherent attitude that cheating is going to be better for me as an individual firm, even if it's not better for the group. But sometimes it can be very difficult to distinguish cheating from just random variations in the market and market conditions. So that makes identifying cartel behavior a little bit more difficult, and it makes organizing cartel behavior a lot more difficult. So let's take a look at the favorable conditions aiding oligopolistic coordination. This is what a lawyer would be looking for if they're trying to press a case against a firm for behaving like a cartel. They want to look at the favorable conditions. Does it make sense under these conditions that this firm could act as a successful cartel? One is that you have to have the ability to raise price. You have to have significant market power. And that can be aided by, and it is aided by, inelastic demand for your product and difficulty of entry. So just like a monopoly, they can keep prices high if there are barriers to entry. One of the other favorable conditions aiding oligopolistic coordination is that in some parts of the world, if you're found guilty of acting as a cartel, the punishments are not very high. They're not very effective. So low expectation of punishment means that if you get caught, it's not that big a deal. Other favorable conditions include low organizational costs, which means mostly that you have a small number of firms that you have to coordinate. A highly concentrated market, so that there are, even if you have a lot of firms, if you have just a few at the top of the food chain, then you don't have to worry about a whole bunch of other stuff going on. You just coordinate the activity of a few key players. If the product is identical or nearly identical, that helps to promote cartel behavior, because you won't have one of your members going off with a differentiated product and affecting the price and the output. Actually, the existence of a trade association can lead to more oligopolistic behaviors, more cartel behaviors, because you get together with your competition on a regular basis at the trade association meetings. And, over drinks one night, you might start to talk about what it means to raise prices or to cut back on output. The unfavorable conditions are essentially the reverse of the favorable conditions. So if there are conditions limiting oligopolistic coordination, that means that there would be things that promote cheating, such as there being many firms in the market. The more participants you have in the market, the harder it is to identify who the cheater is, or if cheating's going on at all, because they may not be changing the overall output all that much, because it's just one of many different firms. That also, if you have lots of firms and you have to have lots of communication between the firms, it's easy to lose. It's easy to have the communications go astray, and so somebody gets the wrong message. If there's independent fluctuations in the market in terms of price, where the prices just randomly go up and down, it's going to be a lot harder to keep prices under control. If prices are secret, it can make it harder to form a cartel. If there's a high fixed cost structure, so think about Boeing and Airbus. Again, those are these two enormous airlines, and they have huge fixed costs that they need to recoup. So if you are trying to reduce output, it's going to make it a little bit harder to cover those fixed costs quickly. And that was going to lead someone to want to cheat to cover their fixed costs. So the working theory of oligopoly works basically in this way. What you have are two opposing sides. They're going to present evidence on the factors that are at work in the case, and a decision maker comes to some judgment. So you have the prosecution, you have the defense, and there's an allegation that these companies are acting as a cartel. Here's the case. Here's the evidence. How many of these conditions are in your favor? How many are not in your favor? What is the behavior of the firms themselves? And there's lots of case law that helps to guide the actions and the process here in terms of the judicial, in terms of the case at law. One just real quick example of this. There were, a number of years ago, there were some antitrust cases brought against broadband providers. And William Baumol, who's a relatively famous economist, was called in as an expert witness to collect some information and to try to present the case for why or why not this was not something that should be a concern. And Baumol used the working theory of oligopoly. He basically said, look at the number of providers. Almost every zip code in the country has at least 2 or 3. We've got mobile wireless that was growing rapidly at the time, which was acting as a new competitor in this kind of market. And the conclusion was very simply, after looking at the diverse factors, looking at the conditions that would encourage cartel behavior or discourage cartel behavior, Baumol and his research team said, you know what? This is about as competitive as it's going to get. It's not really cartel behavior. You have enough firms, you have enough outside competition that this isn't anything that you need to worry about. So that's monopolistic competition and oligopoly. Clearly, there's more rigor. There's a little bit more math involved in these models of oligopoly, but oligopoly is a mixed bag. There's just lots of different approaches to looking at oligopoly and how that is supposed to, or how that strategy and those interdependencies fit together. What we're going to do the next time is to start to take a look at game theory, which is another way of examining oligopoly. At least it's a way we can try to understand oligopoly a little bit better in I think a simpler approach than all the math. But game theory has a lot of extensive applications beyond just whether firms compete or don't compete, whether they advertise or don't advertise. So we're going to look at a number of different angles on game theory and different things that we can use game theory to do at the microeconomic level.